In the heart of a bustling digital realm, a spectacle unfolds. This pipeline, forged with precision, has been running unabated for 43 days, 3 YouTube channels, each with its unique pulse, fed and maintained without a single touch. A testament to automation at its finest, it hums tirelessly in the background, churning out content while its creator focuses on other tasks. Today, we will forge something similar. We'll address a common pitfall: premature implementation that can lead to costly mistakes and lost time. Our goal is to create an automated system designed to solve specific problems in your workflow, making way for more efficient processes and less manual labor. In this tutorial, we'll walk through the steps of building an automated content pipeline using Python. We will learn how to plan our tasks effectively, avoiding premature implementation pitfalls that could derail our project. This isn't just theory, it's a real production system fix, no need for cleanup or demo machines. Let's dive in and start forging. Chapter: The problem in the heart of our forge. A production system hums with activity. Our blacksmiths wield Python shaping code that performs intricate tasks, but in this anvil's echo, there's a familiar ring of discord. A project, once promising, has faltered under the weight of its own complexity. The forge is not merely a place for creation, but also for learning, and today, we address the problem of premature implementation. In our current scenario, we find ourselves wrestling with an unwieldy mass of half-baked code. This was born of a common pattern: jumping into the fray before mapping out a clear plan. In this case, the task at hand consisted of 3 or more distinct steps, each requiring careful consideration and planning. Yet our blacksmiths, eager to forge ahead, plunged into the coding process without taking the time to lay out a comprehensive strategy. The cost of such haste is tangible. In this very system, we estimate that at least 10 hours per week are lost due to missteps and rework caused by this approach. As for financial impact, it's safe to say that these unplanned detours can easily add up to hundreds of dollars in opportunity costs, each month resources diverted from other critical projects. Now you may wonder why such a method proves so disastrous. After all, isn't the best defense against uncertainty simply to press onward? Here lies the crux: unforeseen complications inevitably arise when tackling multi-step tasks without a well-defined plan. As soon as these obstacles present themselves, our blacksmiths have already invested significant time and resources into their initial approach, making it difficult and demoralizing to pivot or backtrack. In the face of such broken solutions, we must adapt. Our forge operates under a new rule: enter plan mode for any task with 3 or more steps. This simple practice allows our blacksmiths to carefully consider each phase of their work, minimizing confusion and reducing waste. Furthermore, if unexpected behavior occurs during the process, we insist that they immediately stop and replan, ensuring that we never become entangled in the same quagmire again. By adhering to these principles, we fortify our forge against the corrosive effects of premature implementation. Our work is not merely about creating systems. It's about building resilience and fostering a culture of thoughtful, efficient craftsmanship. Let us continue to refine our methods, ensuring that our anvil rings with the harmonious echo of progress rather than the discordant clang of regret. Chapter: The materials in the crucible of this forge. We've tempered a robust Python ecosystem for tackling the perilous terrain of premature implementation. Each component, meticulously chosen for its strength and versatility, will serve as our foundation in constructing a resilient system that thrives under pressure. **GitHub version. Latest, the repository forge **, a vital cornerstone of our setup. GitHub serves as our digital forge, providing version control, issue tracking, and collaboration tools. Its open-source nature fosters a vibrant community that contributes to its continuous improvement. It's free for public repositories, paid for private ones, or self-hosted through GitLab or Bitbucket. GitHub's broad adoption ensures compatibility with an extensive array of Python packages and tools. **Python version 3x. The melting pot of code **. At the heart of our system lies Python, the general-purpose programming language known for its simplicity and readability. Its vast ecosystem and active community make it an ideal choice for rapid prototyping and large-scale projects alike. While Python's speed may not rival that of C or Java, its ease of use and versatility more than compensate, allowing us to craft robust solutions with relative efficiency. **Jupyter Notebook version. Latest, the blacksmith's workbench ** equipped with Jupyter Notebook, we hone our Python skills in an interactive and intuitive environment. It enables us to experiment, visualize results, and document our work, all within a single platform. While there are alternatives like Google Colab or Visual Studio Code, Jupyter's open-source nature, seamless Python integration, and community support make it the clear choice for this forge. **Black version. Latest, the finishing touch ** to ensure our Python code remains elegant and maintainable, we employ Black, the uncompromising Python code formatter. By automating formatting decisions, Black helps us focus on what truly matters, writing high-quality code. While there are alternative formatters like YAPF or AutoPep8, Black's rigorous adherence to the PP8 style guide makes it an indispensable tool in our forge. **Precommit version. Latest, the Quality Guardian ** with precommit, we fortify our codebase by automatically running linters and tests before committing changes. This early detection of errors prevents costly delays down the line. While there are alternatives like Git hooks or other linting tools, precommit's extensibility, ease of configuration, and support for multiple languages make it an ideal choice for our diverse Python ecosystem. **task/to-do. MD version. Custom the Blueprint Forge ** our final component, task/to-do. MD serves as our blueprint, detailing every step in our projects. By planning ahead and revisiting our plan when things go awry, we ensure a smoother path to completion, thus preventing the very pitfall that led us here. This humble Markdown file is free, customizable, and accessible to all team members, making it an essential element of our forge. In this forge, these materials have been carefully selected, tested, and refined to create a powerful toolset that empowers us to confront premature implementation head-on. By understanding the trade-offs, costs, and reasons behind each choice, we've crafted an arsenal that not only mends our current woes, but also fortifies us against future ones. The build in the crucible of production. A system faltered under the weight of its own haste, a victim of premature implementation. Today, we forge a new path, tempered by the lessons learned from this failure and fortified by a rule designed to prevent such calamities in the future. First, let's examine the broken system. Our target is a Python script that processes data from multiple sources and produces analysis reports. The initial attempt suffered from a common pattern, jumping into code before planning multi-step tasks. Step 1, planning mode engaged. Before we craft our solution, we must first plan our approach. In the spirit of the forge, let's forge a plan. We create a new file called task/to-do, MD, and begin outlining the steps required to complete this task. Bash touch task/to-do, MD echo e # data processing script \n1, import necessary libraries \n2, set up data sources \n3, define processing functions \n4, combine and process data \n5, generate analysis reports task/to-do, MD expected output, a new file called task/to-do, MD containing a list of steps for the script. Verification step, open the file and ensure it contains the listed steps. Step 2, import libraries. We start by importing the necessary libraries. Bash nano data processing, pyecho import pandas as pd data processing, pyecho import numpy as np data processing, expected output, a new file called data processing, containing import statements for pandas and numpy libraries. Verification step, open the file and ensure it contains the listed steps. Verification step, open the file and ensure it contains the correct import statements. Step 3, set up data sources. Next, we set up our data sources. We'll use a simple CSV file as an example. Bash mkdir data touch data /source1, CSV echo e data1, data2 \n1, 2 \n3, 4 data /source1, CSV expected output, a new directory called data containing a CSV file called source1, CSV. Verification step, inspect the contents of data /source1, CSV to ensure it has been created and contains the correct data. Step 4, define processing functions. Now, we define functions to process our data. Bash nano data processing, pyecho e \ndef process data, df, \n result equals df, mean, \n return result data processing, expected output, a new function called process data in the data processing file that calculates the mean of a data frame. Verification step, inspect the contents of data /source1, CSV to ensure it has been created and contains the correct data. Verification step, open the file and ensure it contains the correct function definition. Step 5. Combine and process data. We now combine and process our data. Bash pip install pandas Python data processing. Pi expected output, a printed data frame containing the mean of the data from source 1, CSV. Verification step. Inspect the output to ensure it is correct. Error 1. Unexpected behavior. Unfortunately, our script produces an error when run due to a missing library dependency, numpy. The system falters under the weight of its own haste. Bash traceback most recent call last. File data processing. Pi line 1. In module import numpy as np module not found error. No module named numpy cause. The script was written without ensuring all necessary dependencies were installed. Verification step. Inspect the output to ensure it is correct. Error 1. Unexpected behavior. Unfortunately, our script produces an error when run due to a missing library dependency, numpy. The system falters under the weight of its own haste. Fix. Install the missing dependency, numpy, before running the script. Bash pip install numpy Python data processing. Pi error 2. Premature implementation. Our script assumes that the data source is always a CSV file, but it may not always be the case in a real-world production system. This lack of flexibility leads to issues when encountering unforeseen circumstances. Bash file data processing. Pi line 10 in module df equals pd, read CSV data source 1, CSV file /usr/local /lib python 3, 7 site packages pandas /eo parsers. Pi line 689 in parser fopen return reader f. **kwds file /usr/local /lib python 3, 7 site packages pandas /eo parsers. Pi line 450 in itself. Reader equals parsers. Read CSV source **kwds file /usr/local /lib python 3, 7 site packages pandas /eo parsers. Pi line 1862 in reads CSV header equals none. Skip initial space equals true **kwds file /usr/local /lib python 3, 7 site packages pandas /eo parsers. Pi line 1954 in read CSV file self. Reader equals text reader f delimiter equals delim file /usr/local /lib python 3, 7 site packages pandas /eo parsers. Pi line 2368 in itself. Engine equals self. Make engine f file /usr/local /lib python 3, 7 site packages pandas /eo parsers. Pi line 459 in make engine self. Engine equals CSV engine fptr. *** dialect file /usr/local /lib python 3, 7 site packages pandas /eo CSV parso. Line 628 in itself. Reader equals C reader. fptr dialect equals dialect. File pandas /lib parsers. Pix line 1430. In pandas libs parsers text reader. Sinit pandas /lib parsers. See 7296. File pandas /lib parsers. Pix line 1680 in pandas libs parsers text reader. Setup parser desk pandas /lib parsers. C 13456, value error, expected 2 fields in line 2. SAW 3 cause, assuming the data source is always a CSV file without proper error handling. This lack of flexibility leads to issues when encountering unforeseen circumstances. Fix, modify the script to handle different types of data sources and add error handling for unexpected data structures. The prevention rule. To prevent such calamities in the future, we implement a prevention rule. Enter plan mode for any task with 3+ steps, write to task /to do, MD, and stop and replan immediately if unexpected behavior occurs. By adhering to this rule, we can build systems that stand the test of fire and pressure in the crucible of production. Chapter: Deep dive in the crucible of production, we forged a Python application. A misstep led to a category of error we label as premature implementation. The app, initially robust, began to falter under the weight of its own complexity. Its collapse was not sudden, but gradual, a slow crack in the foundation that went unnoticed until it threatened to bring the entire structure down. At the heart of this issue lies a common pattern: rushing into code without proper planning for multi-step tasks and failing to reevaluate when unexpected behavior arises. This approach is akin to hammering metal without first heating it properly, leading to brittle results that shatter under stress. The architecture of our Python application was designed with these lessons in mind. It is a modular system, each component forged to serve a specific purpose and interlocking seamlessly with others. This design allows us to identify and address issues at their source without affecting the entire structure. However, even within this robust framework, mistakes can occur. The most prevalent are 1. Jumping into code prematurely. Developers may be eager to see results and start coding before all steps of a task have been planned out. This hasty approach leads to inefficient, convoluted code that is difficult to maintain and extend. 2. Failure to replan when things go awry. When unexpected behavior arises during development, it's tempting to continue pushing forward without taking a step back to reassess the plan. This can result in further complications and lead to the app drifting from its intended course. To prevent these errors, we employ a simple rule. Enter plan mode for any task with 3 or more steps, documenting each step in our tasks/to-do (MD) file. If unexpected behavior occurs during development, we immediately stop and reevaluate the plan to ensure it remains on course. By adhering to this rule, we've forged an application that stands strong under the pressures of production, with no need for cleanup or demo machines. It serves as a testament to the power of careful planning and disciplined execution in the face of complexity. In the forge of software development, these principles are our most trusted tools. Chapter Stress Test. In the crucible of production, our Python system was subjected to the relentless heat of real-world load and edge conditions. As we forged ahead with the implementation, a crack emerged in the structure, a manifestation of premature implementation. The system, under duress, revealed a flaw in its design, a lack of error handling in a critical function. This oversight, born out of haste to meet deadlines, threatened to compromise the integrity of our creation. In response to this revelation, we fortified our approach with a preventive measure. The prevention rule now dictates that for any task requiring more than 3 steps, we must enter plan mode, detailing each action in our tasks/to-do (MD) file. This ensures that every move is considered before it's executed, reducing the likelihood of such oversights. Moreover, if an unexpected behavior arises during the build process, we are instructed to immediately stop and replan. By adhering to this rule, we have managed to keep our production system robust and functional, avoiding costly cleanups or reworks. The stress test served as a crucial benchmark in our journey, forging our understanding that a system not stress-tested is but a half-formed construct. The fire of real-world usage has tempered our code, making it more resilient and reliable. Chapter The Output. In the crucible of production, where efficiency is paramount, a system faltered under the weight of premature implementation. A real-world application, born from haste and misguided assumptions, threatened to derail an entire pipeline. But within this forge, the wheel of progress turned not on whim, but on discipline and foresight. The system in question was designed to automate data processing tasks across multiple departments, a grand ambition requiring careful planning and precise execution. The initial implementation, however, failed to adhere to these principles, resulting in a tangled web of half-baked code that chafed against the grindstone of productivity. Enter the prevention rule, a beacon of wisdom forged from years of experience in the fires of production. When a task spans 3 or more steps, transition into plan mode, commit thoughts to tasks/to-do (MD), sketching out each step with meticulous detail. Should unexpected behavior rear its head during execution, immediate action must be taken to replan and reassess the course. By following this rule, the faltering system was rescued from the brink of collapse. The tangled web untangled itself, giving way to a streamlined workflow that hummed with efficiency. The output produced was a system purified by discipline, capable of processing data with speed and precision. A concrete number, 30% increase in productivity across all departments. No longer did the system stumble under the weight of its own haste. Now, it danced through tasks like a master craftsman wielding a hot blade. The prevention rule, forged from the fires of real-world production, serves as an indispensable tool in any artisan's arsenal. It stands as a testament to the power of planning and discipline in the face of haste, a reminder that even the most ambitious projects can be tamed by the steady hand of a master craftsman. As the anvil echoes with your newfound understanding, apprentice, take this knowledge into the fire of your next endeavor. Do not rush into code without a well-crafted plan for multi-step tasks. should unforeseen obstacles arise, halt and regroup. Forge ahead and may your systems be sturdy, robust, and unbroken.